Now what I'm going to do is just go over some examples and go through the steps that you need to perform in order to be able to do Lewis diagrams successfully. This example is silicon dioxide, SiO2. So the first thing I'm going to do is work out how many valence electrons it's got. Silicon is in group 14, so it's going to have 4 electrons. Oxygen's in group 16, so it's going to have 6 electrons, but it's times by 2, so it's 12. So we've got a total of 16 electrons. The second thing we're going to do is decide which is a central atom. Remember, that is going to be an atom that's by itself. It's always carbon, if carbon is present. So in this case, when we look at this, silicon is the atom by itself, and oxygen has obviously got a pair, so we put silicon as a central atom. Then we just place the oxygens on either side. Third step really is to immediately place a bond between them, because this is the whole point, these atoms are bonded together. And then we start placing electrons. Now we've already put 4 electrons in there, so we've got 12 left. So place them in pairs. So I've used 6 of them. And that's, I think I've used all of them now. 2, 4, 6, 8, 10, 12, 14, 16. Now, the only problem with that, of course, is having used those, that I haven't got a correct structure. If I count the electrons around each atom, it's got 2, 4, 6, 8. So that's 8 there. 2, 4, 6, 8. It's 8 there. Then 2, 4, 6, no, just 2, 4. So there's only 4 there. So although these are good, this isn't. So the next step is now we have to start again, which is why it's often a good idea to do this in pencil. Now, back at the start, we still obviously need them to be connected, but the next step we do is really just placing a double bond. It doesn't matter which side we do it, we just have to do it on one side. So, just first thing now then, we've used 6 electrons, so we've got 10 left. Now I'm only putting 4 here because I recognise that there's 4 electrons being shared in this bond. So this oxygen only needs another 4 electrons, which I've now placed in. The silicon has got 4 electrons from the bond on the right, and then it's also got another pair on the left, so it's got 6. So it just needs 2, so I'm going to place 2 here. So I've used 2, 4, 6, 8, 10, 12, 14, 16. Well, I've used all the electrons here, but on the left I've got, well, 2 electrons here, 2 electrons here, 2 electrons here. That's only 6. So this doesn't work either. So it's getting a bit frustrating, but I'm going to have to start again. Okay, now I'm going to have a double bond on both sides. That's the next step. Notice I haven't gone to a triple bond. Alright, I have not gone to a triple bond because you need to do both sides first. So I've used 4 electrons on the right for the double bond and 4 on the left, so I've used 8, so I've only got 8 electrons left to play with. So if I put a pair there and a pair there, I'm not going to put any more because I've got 4 in the middle here and 4, 2 here and 2 here. That means that's got 8. Now the silicon in the middle, because I've got 4 in this bond here and 4 in this bond here, that means that silicon senses 8 electrons. So actually this one has 8, this one has 8. I've used 12 of the electrons, so I've got 4 left. So if I put that there, that means I've got that I've used all my electrons. I'm just going to redraw that so it's easy to see. So this is the structure I end up with. So just reviewing the counting of the electrons, I've got 2 here. Oops, just going to change that. I've got 2 here, 2 here, and 4 in the middle, so that's 8. Okay, I'm just going to change colours so you can see. There's 4 here and 4 here, so the silicon also senses it's got 8. And on the other side, we've got 2 here and 2 here, and we've got the 4 in the middle, so that all adds up to 8 for this one as well. So that's a correct structure, and we're finished. This is quite a difficult one, and it's exactly the same as carbon dioxide. That's because carbon, like silicon, also has 4 electrons in its valency shell. Now on to the next example. Okay, this is PCl3. Phosphorus has got 5 electrons in its outer shell. Chlorine has got 7 times by 3, because there's 3 of them, equals 21, so we've got a total of 26 electrons. Notice that in counting valency electrons, it always ends up being an even number. Alright, and there's a reason for that, but anyway. First thing is we place the central atom, which is going to be phosphorus because it's the atom that's by itself, and halogens, which chlorine is one of them, are always on the outside. Also, just a helpful thing is to know that halogens never form double bonds. Now we just put a straight bond to them to start with, and we then just start placing electrons. We've used 6 of them, we've got 20 left. Now I'm going to place 2 here. Now I'm not going to place any more because this phosphorus has got 2 electrons from this bond, 2 from this one, 2 from this one, so there's 6 and it makes 8. Now if I then start placing them around the chlorine, I'm putting 6 because there's 2 from the bond here, and that makes 8. And I'm going to do exactly the same thing with the others. Now, you should always check to make sure you haven't used more electrons than you have, because if you have, then you've either miscounted the electrons in terms of the number of valency electrons, or you need to change the structure. Now this has got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, so that's correct, so that's that structure finished. Okay, and that's the final structure you would actually show. Just take care that your dots are visible, and let's move on to another one. Okay, I've deliberately chosen this one because it's a little bit more awkward and it shows a couple of different techniques. We've got 3 atoms. Let's just worry about the valency electrons to start with. We've got 1 hydrogen, so there's 1 electron from the hydrogen. We've got 4 from the carbon, and from the nitrogen we're going to have 5 because that's in group 15, so we've got a total of 10 electrons here. How do we decide on the central atom? Well, the hydrogens are usually the one on the outside. Carbon, if it's present, is always a central atom, so we'll make that the central atom. Okay, so we've got a carbon, and we've got a nitrogen, we've got a hydrogen. Now as soon as we place 1 bond to a hydrogen, we are finished with that hydrogen, because the hydrogen is happy just to have 2 electrons, right? That makes it a full outer shell. Remember, it goes 2, 8, 8, the kind of filling that we have. So we've used 2 and we've got 8 left. So if we place a single bond over here, we've now used 4, and then if we try and put 6 in around the nitrogen, that makes the nitrogen have 8 electrons, because we've got 2 here, 2 here, 2 here, and 2 here. But the carbon in the middle, that's got 2 from here and 2 from here. So that is 4 electrons, no more, but we've used all the electrons. So this doesn't work, we have to make a change. Now the first change I'm making is putting a double bond between the carbon and the nitrogen. Notice I cannot put a double bond between the carbon and the hydrogen because the hydrogen is actually happy. It only needs 2 electrons, we can't put any more. So I've used 6 electrons, I've got 4 left. Now if I place 2 here and 2 here, that means if we count them up, that means I've used all the electrons here. I've got 2, 4, 6, 8, 10. However, if I count the number of electrons around the carbon in the middle, it's got 2, 4, 6. So the carbon doesn't work, it needs 8, so I have to start again. Now at this point, a double bond not having worked, I have only one option. I have to go to a triple bond. Now this means I've used 8 electrons, 2 on this side and 6 on this side. That adds up to 8. So if I look at the nitrogen, I can see that it's got 6 electrons from this bond here, and I put 2 on this side. That means the nitrogen now senses 8 electrons. So if I count those, that's 6 here plus 2, that means 8. Now, if I look into the middle at the carbon, there's 6 electrons here, plus 2, that also senses 8 now, and of course the hydrogen senses those 2. And so this structure now that I'll just redraw here, H, C, triple bond N, is the final structure. That is the correct one. Now just to note, just to remember that one of the exceptions to the octet rule is boron. Boron can only fit 6 electrons around its central atom, which will be boron of course. So if we had BF3, the Lewis diagram for that would be something like this. I'm just drawing them and spacing them out. And that's because boron is such a small atom, it can't actually fit more than 3 surrounding atoms around it. So it's an exception to the octet rule, and you are expected to know that. And that would be just the same if it was BCl3. Okay, it would be exactly the same. It could only fit 3 around it. And of course, chlorine's even bigger than fluorine, so it would be equally true. There is another exception, and that is beryllium, and that's also a very small atom. So BeCl2, for instance, can only fit 4 electrons. This example isn't very often asked. In fact, it's rare. It's more the boron one that gets asked. Okay, and notice that's only got 4 electrons around the central atom. Anyway, hopefully those examples have helped you have some understanding of that. Okay, and that's it.